Okay, welcome to our last lesson for Chapter 6. This is Solving Systems of Linear Inequalities, Lesson 6.6. At the top of the page, you can see a definition of systems of linear inequalities. I'm going to try and make this video as quick as possible, so I'm not going to read that. We're going to follow three basic steps. The first step is that you're going to graph each inequality. Most of the book's examples use two different inequalities, but it could be more than two. We are going to figure out by substituting for 0 which side of the line we're going to shade, the true or false side, and then we're going to shade the sections and find where the overlap is. And what I mean by overlap is this. So I'm going to go ahead and just do a kind of a fake one here. Let's say I found out that this side of the line was where my solution lie. And let's say that I figured out that on my second line over here, that this side of the line is where I found my solution, okay? And I shade that side of my other line, okay, if I solve for those inequalities. And I think it becomes pretty clear to see that where they overlap is right here in this kind of pinkish hued section over here. So of course the solution, one of the solutions is in here, one of the solutions is in here, but the solution for the system of linear inequalities is this section in here. Okay, it's time to put the theory into action by graphing the system of inequalities. So we have two inequalities here. We'll call this 1 and we'll call this 2, and we're going to go ahead and solve for those. So the first one, it's already written in the form I'm looking for as y isolated. So we have y is less than 2x minus 3. I've just copied the same one over here. And just so we know, I'm just going to make some notes over here, that of course this represents our rise and run, which means our rise is 2, and it's 2 over 1 actually, and that's our run, and that's our rise. That's a 1. That's a rise. And of course, the negative 3 actually represents our y-intercept. Okay, that's our y-intercept. So that's kind of a way to read it. This one's already in the form, so we can go ahead and graph this the way it is. So I'm going to go ahead and start at negative 3. And we know that we're going to go up 2 and across 1. So 1, 2, 1, 1, 2, 1. And the more we put in, obviously the more accurate we can make that line. But I think 1, 2, and 1. We can stop there. Now the thing to remember is, because this is less than, we don't have a straight or a consistent line. In this case, it has to be a dotted line. Only equal to has a solid line. So we have to make sure to remember to make that dotted. Now we can go ahead and replace our variables with 0 to see if it holds true. So what we're going to do is replace, or I'll use another color here so we can see it a little clearer. We're going to go ahead and replace our numbers with 0. So we're going to go ahead, and replace our, come on here, work with me. Replace our y and replace our x. So that's 0 is less than negative 3. And of course, that doesn't work at all. So we're going to shade, or actually we're going to go ahead and fill the false side of it, which is this side over here. So I'm going to go ahead and just run this up here. It's not perfect, but you guys get the idea. So it just takes a minute here. I'll do it as quickly as I can. I'm going to fully shade in my false side of my line. Okay, now I can move on and solve our second portion of the equation, or sorry, our second inequality, and that's 2x plus y is greater than 2. What I want to do here is I want to isolate y by itself. So to do that, I'm going to subtract 2x from this side and subtract 2x from this side. And what that leaves me with is going to be y is greater than negative 2x plus 2. And I'll use the same color and remind you that, of course, this is our rise and run. Rise over run, and which means it's going to be down 2 because it's negative 2 and across 1. And this represents our y-intercept. Okay, kind of remains the same formula, same format, I should say. And let's go ahead and graph this. Let's make a green. That should make an interesting choice. So now we can go ahead and graph that. Because our y-intercept is 2, we can go ahead and make our first dot at 2. And then it's going to be down 2 across 1, down 2 across 1, down 2 across 1, down 2 across 1, down 2 across 1. And that's enough that I can start to make the connection and make a line. Again, this is not equal to. It is greater than in this case, so we're going to go ahead and make a dotted line instead of a solid line. Dot, 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 dot. Some people might call it a dashed line, whichever you prefer, and we'll substitute for 0 and see if that works out in our favor. So we'll go ahead and call this, oops, that's on eraser mode. We'll go ahead and substitute for 0, and we'll turn this into 0, which would mean that 0 is greater than greater than 2. And that is not the case. So we're going to go ahead and shade the negative side of this as well. And let's use the same color. See the green so you can see it. I'll do this as quickly as possible. Okay. So basically, while I'm shading this, what this represents is that anything on that side of the line that's been shaded is a possible solution for that because it's a system, not one set of ordered pairs. And so what we can see now, I'll use a different color to kind of highlight what we've done here, is what we can see here is that we have our solution for our first inequality here in the pink, right? And we have our solution for our second inequality here in green. But this, I guess we'd call orangish color in here, that's my eraser. This orange colored one in here is our, it's a system of solutions. Because anything represented in this area here and beyond, of course it would keep going, is a solution for these inequalities. And that's how we get it done.